Is that showing up on the video? Oh, I can see it a lot better in person. But there's a light flashing there. Alright. So we're in Joule Thief mode. We have a 2 farad capacitor there, 2 farads, and then also this 0.1 farad capacitor, or 0.01 farad. So we've got essentially 2 farads there. And that's the voltage on the capacitor there, 1.874 volts. We're in the 2000 millivolt range. Sorry, gotta let the dog in. Hi, Maggie. Okay, and I think you can see that that light is flashing. We've got the 1 microfarad capacitor in the circuit and the switch in the resistor mode and GhostLight mode on the mode switch. And the current, the current indication is not in the loop right now, so don't be worried about the fact that it's indicating no current in the 2000 microamp range. We're just not hooked up. That's what this clip is for over here. Now what I'm going to do now is I'm going to take this clip as part of the current loop of my little 2 meters here. Normally I would hook this, I would disconnect the negative lead and hook this lead to the circuit, and the negative lead to the one of these other leads here, and then the current meter would be in series with the circuit, but right now it's not. I just have its free lead over here, and I think you can see that the light is flashing and we still haven't lost any voltage on that capacitor. What I'm going to do now is I'm going to take this free current lead and just hook it up to my toolbox over here to the I found this out because I was putting this clip over here just to hold it, and finally it chewed through the paint, and so I got a connection. But if I hook it up to the drawer slide, I get a good connection. Now watch the light as I do that. I'm going to touch it now. I think I'm going to touch it now. There. See how the light flashing got faster and brighter? Okay. And we might have a little current drain now on the voltage, but we're still not getting anything indicated on the current meter, of course. But that light is definitely flashing faster and brighter. Okay, I'm going to disconnect from the toolbox now. Okay. And now I'm going to disconnect this 1 farad capacitor. Woo! And I think you can see that that really makes the light come on strong in this mode, and of course it creates a big current drain. So let's go to the normal ordinary GhostLight mode. Okay, so I have a MPS A18 transistor in there. Okay, now in the normal ordinary GhostLight mode, we've stabilized from that huge sink that we just caused by turning the light on brightly, and there's no visible light in there until I touch the terminal, and then I get a really, really bright light. And I also get a little bit of current drain when that happens, but not really a lot. So I'm touching now, got a huge light, and very, very little, if any, current drain. Okay, now I'm going to untouch. Alright, and the light goes out, and we still have the same voltage on the capacitor, about 1.57 volts. Alright, now GhostLight mode, diode on the diode switch. I can touch it anywhere and I get light. GhostLight mode on the mode switch, and the free end of the current sense. Look, I pick it up and it's already coming on. I'm going to hook this up to my toolbox again. Hook up, unhook, hook, unhook. So I'm just going to clip it in. There's without it clipped in. A little bit of light from me holding it. Now it's clipped in. Huge amount of light. And a little bit of a current drain. Still nothing here because this really isn't in the circuit, but the voltage dropping shows you that there is some current being drained. A millivolt per second or something like that. So you could figure out how long that it might take for this nice brilliant GhostLight to dim at a current drain of, or a voltage drop of a millivolt per second about. And a voltage of 1.4 volts or less. Alright, we've got no battery hooked up, people. No external power supply. The only thing it's hooked up to is my toolbox and the earth ground. And no touch of the Joule thief is necessary. So this hooking the toolbox up to the current sensing part of my system is, I think, equivalent to hooking up the positive side of the battery to the toolbox just directly. So let me get a jumper here and we'll test that hypothesis. Okay, so the positive side of the capacitor is there, and yeah, already the light is on. Oops. Positive side of the capacitor is there. Now I'll take that and hook it to the toolbox, and yeah, sure enough, that's it. So I hook the positive side of the capacitor to the toolbox. The normal earth ground place of for the earth ground in the circuit, and I get a low current drain. This is not real current here, okay? The dropping of the voltage, the millivolts per second dropping of the voltage, is indicating that there is a current drain on the capacitor. But look at that light, man. You could read by that light easy. And that's with the diode and ground, or rather GhostLight mode selected on the mode switch. Oh, I did one other thing. I put in a 1 megohm resistor from base to collector instead of 220K, and I have this 22 ohm resistor between the positive rail and the collector of the 2N22 or MPSA 18A here. So there's a little bit more resistance in the circuit than it had before. Now if I switch to Joule thief mode like this, it'll probably blow out the LED or the transistor, so I'm not going to do that. I'm just going to leave it in GhostLight mode. What you're seeing there is the GhostLight. There's a little bit of charge on the capacitor, 1.27 volts, and I'm hooked up to the toolbox with the positive side of the battery, and the earth ground to the base of the low voltage transistor through the switch there. Alright, now I suppose you could probably do the math and figure out what would happen if instead of a 2 farad capacitor charged to 1.2 volts, if I had a 10 farad capacitor charged to 3 volts or 5 volts, you would be dropping the voltage at maybe 1 millivolt every 5 seconds or so, and to go from 3 volts down to the 0.45 volt cutoff of this system, well, just call it 2 volts or 2,000 millivolts. So if you're taking 5 seconds per millivolt, 5 times 2,000 is 10,000 seconds. I would expect this light on a 10 farad capacitor to run for 10,000 seconds, easy. Wouldn't you? Thank you for watching.